So hey guys, we are back with the 6th day of the bootcamp, and today what we'll be doing is we'll be creating a typical design using this Turtle Python again, and this one's gonna be a little bit difficult, so I would recommend you all to just do it with me side by side so that you can kind of get the results immediately, and also it'll be easier for you to understand the complete pattern and how it's created side by side only. Yeah, so let's just begin by importing our turtle module star. Okay, after that, this time we'll be using the random module also. We need to use it because what we'll be doing is we'll be creating stars in the background and we want their positions to be randomized. So we'll be using the random function from the random module and we'll be randomizing their positions using random function. Okay, so now we'll be creating the starry background. First of all, I would like to tell you about a small little feature that is available in Turtle Python. We can use screen as our variable too, or to put it in better terms, we can even use our screen and assign it to a variable. For example, I'll be using the screen function to assign it to a variable s. Now we can use this variable to kind of assign a title to the screen and also vary its width or height according to our wish. Okay, we can even randomize it using random function. So for now, what I'll be doing is I'll be giving it a title. Let's say my title. I'm sorry, I can't think of any better one. And I'll be assigning it a width of, let's say, some variables w and h, and for that we'll have to assign these variables a value of maybe, let's say, 700 and 700. Yeah, let's just keep it that way. I think it looks perfect this way. And now let's just change the color of the screen. Oops. And let's keep it black, because every time we keep it black and it looks really amazing. And now this time we'll be assigning a variable to assigning a turtle to also to a variable. We'll be using variables a lot this time, so bear with me, and let's just assign it to a variable star, because our turtle is also going to look like a star in this program, and we'll be using turtle function to assign it to a variable star, and then we'll be giving it a shape. Let's say for our star or for our turtle over here, we'll be assigning it a shape of circle, which is a little bit circular. Okay, circle, yeah. And we'll be giving it a size of, let's say we give it a size of 0.05. Yeah, 0. Yeah. And let's say we give it a color of white. Yeah, looks perfect. The turtle will be of width and height 0.05, and it's gonna be of circular shape, and it's gonna be of white color. We need to assign these two parameters to shape size variable even if we keep the shape as circle, because if we vary these two variables it will become a little bit elliptical. Okay, so if we keep them equal it will come out perfect circular, so let's keep it that way. Now we'll be using star.pu function. This is just the penup function. It's a short form for that. You can use this function too, or you can in general use penup function too. It's your choice. And let's assign speed to it. We'll keep it fastest by passing a parameter of 0. And now for creating the starry background, I'll be using the for loop. Now comes where I need to assign the positions to the star, and as I said, they'll be randomized. So let's say we give its x parameter a value of randint, and let's just vary them in this way. You can choose w by 3 also, it's your choice, but I'll be keeping w by 2 only over here. You can vary them any way you want them to. And let's just save a little bit of time and give this as height and assign it a parameter y over here, so that they can vary along this way too, along the y-axis too. Now I'll be taking the turtle to its initial position, or let's say to the position x comma y, whichever position it may want to go. And now we'll be using a new function over here. That function is called stamp function, and what this function does is it leaves an imprint of its own whichever position it crosses with time. Okay, so whichever place it goes, it just leaves its imprints. Okay, now we'll be working on the ripple effect that we'll be giving on the starry background. Okay, so for that we'll be using, let's say, a variable cycle, and we'll be assigning the turtle to this variable cycle, and we'll be hiding the turtle this time. So we'll be using cycle dot hide turtle, or simply ht. It's a short form for hide turtle function. And now to control its speed, we'll be assigning it a color as white. So now we'll just keep our pen up using the pen up function and varying its pen size using the pen size function, and let's just keep it 2. Yeah, looks perfect to me over here. Okay, so what we'll be doing is, now we'll be assigning, or rather we'll be creating a variable named radius, which will be controlling the radius of the circles, or you could say arcs of the circles that are going to be created using this in this ripple effect. Okay, so let's say we assign it a value of 5 right now, and we'll be using another variable over here, let's say cumulative extent, and let's assign it a value of 0. Now what is the purpose of using this variable over here? So first of all, let me tell you what it means. So cumulative extent. So what is the purpose of defining this variable over here? It defines the extent of the circle that we are drawing on in the ripple effect. Let me explain this variable to you with an example. So cumulative extent for a circle which is completely drawn, one whole circle is 360. Okay, and if it's lesser than that, it may be a fraction of 360. For example, let's say 240 or maybe 180. 180 is for half circle, 90 degree, 1/4 quarter of a circle. Okay, so that's how we define cumulative extent of the circle over here. And now we'll be starting to create that ripple effect for I in range. Let's keep it 1000, and after that we'll be defining another variable extent over here, so that we can control the ripple that is being drawn on the presentation screen. And since it has to be randomized, so we'll be assigning it to the random function over here, random star 90, yeah, just to control its extent. And now we'll be assigning colors to it. So in the first day of the tutorial, on the first day of the bootcamp too, I used a similar way to assign colors. So this could be a good revision for you all too. So I'll be kind of assigning various different colors to the ripples. Maybe I'll be trying to do that, and using this array of different colors that we can kind of create over here. Okay, 0.255 and same value to be repeated thrice. Okay, cool. So next, what we'll be doing is we'll be defining we'll be creating the circle using the circle function. We'll be keeping its radius as 5, or just assign it radius, and keep its extent, and also we'll be giving it a color, and color would be of color only. Yeah, and yeah, now next we'll be increasing its cumulative extent each time one circle is drawn. Okay, and now what I want is, if cumulative extent is greater than 360. For example, if we draw a complete circle, then I want that the cumulative extent to be reinitialized. Then I want the cumulative extent to be reinitialized with 0, and the radius to be increased by a factor of 3, so that the ripple does not overlap. We want the radius of the ripples to increase because we don't want those ripples to overlap, and otherwise there's gonna be only one circle, and they'll be all the circles will be getting stacked over one another. Okay, the ripple effects will stop growing. And now what I want to do is simply I just want to pull my pen up, and I want my turtle to go to a specific position which I feel it should be, let's say this. Yeah, and after that again I want the pen to be put down, and just let's just use the set heading function so that we can put our head straight, put the head of the turtle straight. Yeah, so now I think since the code part is complete, you do realize that this code is a little bit complicated. So I'll be putting all the code on our GitHub account, and it will be really well described. You can go check it out and you can try it for yourself from there too, and you can kind of practice this code maybe once or twice, and you'll see everything get crystal clear to you really easily. Let's just quickly save it, and let's just run the program. Yeah. If you did like this video, please give this video a big thumbs up, and all the code taught in this video is already provided on our GitHub account. You can go and check it out, and I hope you understood whatever was taught over here, and I hope you implement it in your own PCs too. Okay, bye.